There should be one more click, of course. No? I'm live? Okay, incredible. Great. So this is the last class. We will have project presentations next time. I put up a sheet for signing up for project presentation schedule. There is one slot, time slot available next class. And there are 3 time slots on Tuesday, okay, from 8 to 11, from 12 to 3, and from 4 to 7 p.m., okay? So you need to sign up for one of the slots. I have to ask people who already signed up to please update their information, because I forgot to put a field for the project title. And so I guess, you know, several people from the same project might have signed up. And of course, I want only one presentation per group, right, and not multiple ones. So I will need to, well, in case people of the same project disagree on the time, I don't know, I will choose them. Okay, so ideally, there should be only one entry per project. But if people have multiple entries, I will use, you know, any time slot that anybody likes, I guess, because I don't know what to do otherwise. And I plan to tell you at the end of the day today, the people who are going to present on next Thursday. Okay, there are some groups that want to go early, and I plan to then tell you on Sunday or Saturday, one of the 2 days. So essentially, we close around Saturday 12 noon the sign up. I mean, it's not that I close it, but at that point I will make the schedule. You know, if you sign up beyond that, I will have to see if I can make a, you know, where I can fit you essentially. Okay. So over the weekend, I will tell you what the precise schedule for Tuesday is. Okay, so a presentation is about 10 to 15 minutes. I think 12 minutes is a sort of average. You are wondering, you know, what should go in a presentation. Essentially, I want something like this. I want maybe no more than 2-3 slides, unless you have something very special to say, describing the project, what it is and what it is, what problem it tries to solve. Then I would like a project demo. So I would like you essentially to give a demo of how it works, okay? So that I can see how it works, so that when I will look at the code, I will know roughly, you know, what to look for and what's where, etc. Right? And then I will also want if you did anything special that was difficult technically, I know that some of you are, you know, some of you are using the channels API, some others are integrating with this JavaScript library here and there, etc., etc. If you can say a couple of words about how you did it and what is special about the project, you know, what are the difficult things. So generally, I mean, from previous years, a time slot length of about 12 minutes, so 5 projects an hour is a reasonable schedule. I think from the spreadsheet, we have 40 projects. I don't know, Rakshit can check, but I think that's the number we had up to a couple of days ago. And we have more than enough slots, right? Because a 5 an hour would be 15 every 3 hour period. And I have 45 slots even only on Tuesday. So we have, you know, we have a little bit of slack time. What I would like to ask, I mean, of course, you have to attend only the session in which you present. Otherwise, you know, I and Rakshit will be doing the marathon day, but you don't have to, obviously. Okay, but I would like to ask you if you can stay for the 3 hour period, you know, to sort of, you know, cheer up and build a bit of audience for your, you know, fellow presenters. That would be sort of nice. Okay. Let me know if you need anything. I will have this Mac converter for you to use so that you are able to project, you know, from VGA to Mac. But I can lend this to you only for Macs that are the new model. There is an old model Macs, you know, that used to have a sort of different port. And unfortunately, I think I lost my previous converter. I have to see whether I can find it in the office. So if you have an older Mac, please let me know, okay? Also, some laptops have these, how is it called? Oh boy, HDMI, yeah, thank you. HDMI output, but not every classroom has the converter. So HDMI to VGA. So I have to check. I'm not sure I have one myself. Does anybody have one? Do we have one? No.
Isn't there an HDMI?
There should be, but I couldn't find it. There is, I mean, in this classroom, for example, there is not. So, But let me know if you need HDMI, and then I'll essentially pick up a converter somewhere. I mean, a tech staff will give me one, or I'll get one, or in some way. Okay, so let me know essentially what you need for this to work for you. Okay. Are there any questions on the final presentation? By the way, I am somewhat sorry. I was trusting my phone for the times, and then 2 days ago I noticed that for I don't know how long, but I think most of the quarter, my phone was off regularly by 5 minutes. I don't know if you know. It's because I was traveling and I removed the sync with the network time because I was in a US state. I don't remember where I was, but it was continuously putting me in the wrong time zone. I don't know why. Okay. But so you may have noticed that I was starting exactly 5 minutes late, and I hope I was not finishing 5 minutes late every time. But so if you were wondering, that's the reason. At some point, I walked into a meeting exactly on time, which rarely happens to me, and everybody had already begun. And so I was, what's going on? Normally, people don't start so much ahead of time, and then I noticed. Okay, so sorry for this. I mean, maybe you were not so sorry. You could wake up 5 minutes more, but okay, that's why. Yeah.
So this is a 10 to 15 minute presentation. For larger groups, is every team member expected to speak for part of it?
It would be good if you were all there to take questions. Okay. Speaking, you can do how you want. Okay. There will be another form that I will give out. I'm sorry, this is a form period, I guess. Oh, by the way, we have here the TA evaluations. So at the end of class, we need to have you fill it in, and one of you to bring them back to the School of Engineering. What did I want to say? Oh yes, there will be one more form. It's a sort of peer evaluation form. You have to say there what you did and what the other people in the group did. Okay. I have to reveal the full purpose of it. I think I announced at the beginning of class that I would have these peer evaluations. But basically, for normal projects, people do a little bit more, people do a little bit less. Some people have a stronger background, some people have a weaker background. And so in the end, I don't pay, I mean, I read it, but I don't do, I don't try to finesse, this is a B plus or a B plus plus or an A minus minus or an A minus, we can pretend, but things in life are more imprecise than that. What I do is that, sometimes I read in a group that, person X did nothing. And, in that case, I do differentiate the grades. So, it happens rarely, but there is sometimes in projects these people that don't even show up at the project meetings, and the purpose of the peer evaluations is essentially to be fairer to, the people that carry the burden versus the ones that, don't work. Okay. So I will be circulating such a form. I see that there are, do you have questions on the form? No, okay. I think I announced it. I mean, I do it every time I have projects just to ensure, that there are, good group dynamics. I think holding everybody a bit responsible works best. Also, you may have noticed that I was very late in cranking the handle with CodeGrader to assign grades. This is because in reality, I was working quite a bit on the algorithms behind it, because I was a bit unsatisfied of this phenomenon, okay? Not in this class, but in other classes, CodeGrader is used in various places. Students have discovered that, hey, if we give 10 to everybody, out of 10, we are infinitely precise and we get top grade, So what to do about those? And also I was unsatisfied instead in this class that, due to the fact that grading is difficult, some assignments had very differing grades, and I wanted to have some better way of doing it. So what I did is this. I give, now you don't see this, but you can go to the CodeGrader blog to see a screenshot. But I built some much better information about, who has been graded with what level of accuracy for the instructors, okay? And I've asked poor Rakshit, so give him a hand when you. I mean, he did a lot of work for the class. I'm just mentioning it since we have the evaluations. But he's okay. I mean, he does not depend so much on them. But but I've asked Rakshit to actually take a second look at all the submissions that were graded in a way that was too different in the grades. Because of course, CardGrader can do its own statistical magic to some extent. But if you have like 210, okay, fine. Do I choose the 2 or the 10 or which middle of the 2? And statistics helps you, but a second pair of eyes, helps you even more. There is no substitute. And this also creates an incentive for students, not in this class, but in other classes that have taken place, to be more precise. Because if now the students give 10, 10, 10, 10, 10, but the instructor, reassesses some of those submissions that got 10 and were not 10, then, the students' precision will be lower than that. So it's, anyway, you don't need to be concerned with this incentive system, but essentially I thought this would lead to much fairer grading and much more precise grading. So that's why I was building this code. The problem of building this type of code is that once you mix student grades with teacher grades, you want to mix them in a different way, right? Because you want to give more belief to the teacher. And so I actually had to spend a lot of time not so much coding the algorithm, but verifying that on the previous tests it wouldn't give two very different results, etc., etc. So over this weekend, I pushed the final version, and so Rakshit can do the final grading. So thank you very much. So this was the other announcement I wanted to give. How many of you are planning to take mobile apps next quarter? A few. Okay. Yeah. I'm planning, for those of you who are interested, to do it in a different way. I hope I won't be thrown vegetables on me. But essentially what I plan to do is try to use iClickers to get more class participation. Okay, because I mean, you are the strong ones and you are the ones that showed up all the time, but I would like, more of the class to behave as you did. So thank you for coming, by the way. Yeah.
I mean, I took bowl ups last year.
Yeah.
So that would probably
Yeah. No, I agree. I just feel bad, I would like to build an Android app to replace iClickers, actually, but maybe that will be what we will be doing during the class. It's only that I didn't want to do it during the break, because during the break I need to. One of the very annoying things about teaching these classes compared to teaching more theory classes is that what you taught last year doesn't really work this year, because they changed a bit the system below your feet, and so you need to every time check that you can still build everything you need to build, etc., etc. So that's what I want to do. Okay, I think this is it for announcements. I don't know if there are any other major. Are there any questions? So I was wondering what to do for this last class. We can do basically what we want, right? I made a mistake this year. Maybe I went too fast at the beginning, but I wanted to let you build applications. So I finished a little bit earlier what I really wanted to tell you about the course. So I was asked to go over deployment once more. I don't know if this is a general wish, but if it is, I can spend some time on. You see, if I had clickers, I could ask, A, B, C, D, and we could do it by order. But we will raise our hands for the people who are here. So one thing is to go over how to host your app again. Another thing is that I have the impression that various people have always questions about Ajax. And so I don't know if it's useful that I build some other thing in Ajax. For example, I don't know, yesterday I was talking to people who want to regularly get a data feed from the server. And so I want to essentially go over that. I don't know if that would be a good topic. Would you have any other topic that you would like me to talk about this time? Yeah? No. So some of the other weeks I had invited a friend to talk about how to build a company. In the meantime, I've become a bit more expert about that. Would that be also a topic of interest? Is anyone of you planning to try to build a company or not? Okay, I can talk about it briefly at the end, or at some point. I have a big problem as an instructor, actually. My problem is this: the more I know things, the more my mind summarizes them into the essential. And so everything becomes, instead of longer, so, you know, typical professors have courses that become longer in time because they figure out that they can say more things. I instead figure out what are the few things worth saying, and then I try to say only those. And so I'm really in trouble with every kind of topic. You know, the more I teach it, the shorter the class becomes. I don't know what's happening. It's a reductionist approach to teaching. Okay, let me see if I haven't forgotten my glasses. Okay, what would you like to do for starting? A bit about hosting. So let me do a poll. How many of you plan to host on Google App Engine? Okay, quite a few. How many of you are choosing Python Anywhere? No? I thought it was a super success. Two people. I mean, one project, their project. So I'm curious, actually. Let me ask you, why are you choosing App Engine?
Mostly for the channels API.
Oh, Channels API, yes, very good. Yeah, the Channels API. Did you manage to get it to work?
Not yet.
Ah, okay. Oh, okay.
I don't really know.
You don't really know.
No, because I'm working on a project with another person from my senior game design class.
Okay.
We're making the server for half of their games.
I see. I see. Others chose App Engine. Would you like to say why they're choosing it? I'm just curious. I mean, many people raise their hands, so nobody wants to speak. You are choosing App Engine? Are you choosing it to host on Google App Engine? No. Okay, fine. What about you? Sorry? Python Anywhere. Okay. Yeah. So, okay, let me see. Actually, I got a message today that deploying on Google App Engine today seems to be a bit on the slow side. Let me do one thing. Okay. So to deploy on Google App Engine, you can do it with command line, or you can do it with the Google App Engine launcher. Okay, I told you that the main reason I use the Google App Engine launcher is simply that I don't need to type the password in front of you. Okay, because otherwise, first of all, a little bit about security. If you plan to have an application online on Google App Engine, I would really advise you to use two-factor authentication. Okay, this is available on Google. It's actually one of the great advantages of hosting it on App Engine from my point of view. You know what I'm talking about, right? This means that you have to put on your phone an app, or else you can receive by SMS a code every time you try to log in, or maybe every month you try to log in. And so when you log in addition to the password, you have to give this code. Okay. Now, the flip side is that your password alone doesn't work anymore as authentication. So if you use Google App Engine, you have two strategies. If you use the command line tools, you have to generate what is called the one-time passwords. So these are 16 characters that, letters or numbers, so 36 in total of them. And you can generate as many of these one-time passwords as you want. And these one-time passwords are used for one application at a time. They are always valid, and you can revoke them. And they're also impossible to remember. So unfortunately, the way it works is that you have to keep them somewhere safe. And there is no such safe place, unfortunately, really, but on your laptop somewhere. And then you need to cut and paste them into the command line whenever you try to upload things. This is a so-so solution. It's not really great. And so the better solution is to use the App Engine launcher, which is what you have here, because in this way, when you upload an application, you can follow the normal flow and having the password and this authentication code that is given to you by the phone. The reason I really recommend this, I mean, if you're just playing with it, don't bother, I guess. But the reason I really recommend it, and I do it also for all my email and for all my other documents, etc., is that especially when you start to having a website, you become a target to hacking to some extent, depending on how interesting the company is or interesting the website is. But also, if you start to get user data, you start to have some responsibility towards the user data you are storing, even if it's only username, password pairs, etc. So you need to protect the access to your server. And I think it's a very good practice to immediately go to two-factor passwords. They are not a very big deal, and they're much better, much safer. Okay. So here I have my application that I had defined as what was the name? Sorry, I wonder if I can resize this. I can resize it, but I cannot change the width of the columns, it seems. But this was, you see look at teaching, okay? This was the app that I had built the last time. Okay, and so if you are going to deploy on Google App Engine, okay, you need to download the source code of Web2Py. Because in Google App Engine, and I believe also, well, in Python Anywhere is different, because in Python Anywhere, Web2Py is already running on Python Anywhere, and what you do is upload your app to the Web2Py. You upload your packaged app to Python Anywhere, and you do it that way, okay? But instead, for Google App Engine per se does not run Web2Py. Per se, the only thing that it would come with is something called Web App 2, which is a fairly low sophistication web framework. Okay, I mean they did it. They gave it because it's better than nothing, I guess. It's actually not too bad to use a Web App 2 if you are just building an Ajax backend, because if all you have to do is get a request, extract the parameters, and do something with it. It works kind of. It's not fantastic, but it works. But if you have to serve a real website with all the HTML, etc., then Web2Py is much better. But Google App Engine does not know per se of Web2Py, and so you have to upload the whole set of code to Google App Engine. One thing that you have to be careful is this. Google App Engine uses, I don't know exactly what, because it's confidential information that I don't have, but it uses some way of running Python on top of some kind of virtual machine. At least the set of packages are all different, okay? And the package loader is different, okay? So they check that the set of packages you're using is limited to packages that run in pure Python. Essentially what they do is this in Google App Engine, to give you a rough idea. They have these real machines that are running at the same time multiple customer applications, okay? And so the problem is that they needed to keep these applications isolated. They cannot allow a Python application, to poke into the operating system and see what's the set of running processes or whatever, right? So they want essentially to limit what you can do. Normally in Python, if you want, you can fairly well hack into the operating system. For example, if you know it's Linux, you can say simply commands get output of PS, and this gives you the list of running processes. So you can do a lot of things. You can write files, you can read directories with certain privileges, but you can do quite a bit, okay? And they don't want this to happen. They want to enforce isolation, obviously. So there are a number of packages that you cannot use, and unfortunately there are also, so you cannot create files. This is one limitation. And some of the packages that you may want to use are unfortunately really very useful. The ones that I miss the most, for instance, are SciPy, the scientific extension of Python, okay, and matplotlib, which is this beautiful plotting lib. Matplotlib you can get around, because if you want to build plots, perhaps a better approach, rather than producing a JPEG or a PNG on the server and then shipping it to the client, a better approach is to give the client some, the data via JavaScript, and then using a JavaScript plotting library, of which there are many if you search for them. But I've used in the past extensively the Google charting API, and I like it quite a bit. but it's one of many, okay? So if you need to do drawings, you can use that. But there are in general many other super useful packages that you cannot use, especially, I don't know how relevant it is to you, but for example, for image processing, you have PIL, P-I-L, Python Imaging Library, but you don't have other things. Like you don't have OpenCV, for instance, that does a lot of very nice image processing for you. You don't have, you know, I was trying to build an app that processes movies in a certain way, right? And you don't have FFmpeg to take a movie apart into frames and put it back together. No, it's a big. Why don't you have these kind of things? Because the tools themselves are written in C code that is difficult to isolate from other running instances. Luckily, Google App Engine did a long time ago an exception, and they sort of special cased a version of NumPy. NumPy is the numerical library of Python. And so NumPy is available on Google App Engine. And I love NumPy, by the way. It's way, way, way better in my mind than Octave or MATLAB. I mean, MATLAB comes with more toolboxes, but NumPy, if you have any kind of numerical problem, it's really fantastically well done. So you should give it a look, okay? But so essentially, Google App Engine comes with this set of limitations. I also told you that Google App Engine is this thing that for us is very simple because it's it will run pure Python or pure Java or pure Go and now also pure PHP code, okay? There is another solution if you, so Google essentially offers 4 solutions. Let me do a quick summary. One is App Engine, which is essentially, works at the level of abstraction of HTTP call, okay? Everything is an HTTP call. You want a cron job? Fine. There is a way to define to get a particular HTTP call to a particular URL every often as you want, okay? But so in Google App Engine, you don't even know where you are running. You just run an application and you just say your only task fundamentally is how do you answer to HTTP calls? You don't have any other thing. You have a lot of APIs, like you have a task queue, but what is a task queue? I put in a task queue HTTP calls that will be run eventually, right? So everything is based on this notion that nothing runs forever. Everything runs triggered by an HTTP call, and you don't worry about how many instances of the process are running or how many instances of anything is running. It's essentially, you know, very beautiful in my mind, the level of abstraction in which you throw completely away the operating system and even the notion of a single machine. You don't care about machines. Well, you care because you pay for them. But more than that, you really don't care about what is a host, how many hosts, whatever else. Everything, including concurrency, is managed by this level of, you know, you do an HTTP call to something, which can also be your service. I sort of really, really like that. But it's somewhat limited in terms of language, okay? So this is App Engine. Then there are managed VMs. Managed VMs are essentially these. They are a fairly new thing, but you give some instructions on how to build a virtual machine. Actually, this is done via Docker, which is a new tool that has been coming out in the last year or so, maybe 2 years, but that enables you to describe a running environment, okay? And so, for example, in Docker, you say, it's based on Linux. So you say something like apt-get install, say, FFmpeg, apt-get install, whatever, other packages you might need, okay? And then you still have here the app.yaml file that will go from HTTP calls to code. Okay, it will tell you when you get a call to this address, this is a code to run to reply to it. We will see shortly how this app.yaml behaves. Okay, so but the beauty of managed VMs is that since you give the how to say the declarative instructions on how to build a VM, then in the running environment, as many of these as needed are brought up. Okay, so that if you receive a higher traffic, it's not you, but it's essentially the running environment that will decide how many of these virtual machines to spin up. You have some control on these policies, okay? You can say, you can basically say, how long does it have to be the wait for an HTTP call before a new instance is spun up? For example, in CloudGrader, I defined that below one, I think I defined it like this, okay? I would have to check. But I think that in CloudGrader, I defined it that if a new call waits for CPU for less than a second, I just let it wait, because a second is low enough. If you wait for more than a second, I span up a new instance of the server, okay? And so I ensure that there are always enough machines so that a new hit on CloudGrader will wait for less than a second on average before you can get a free machine, okay? And so that's why, you know, the response time in theory should be always below, you know, 1 second plus whatever computation time I have in the tool itself. Okay, and so these managed VMs also scale automatically. So this auto scale, and this also auto scale. Auto scaling is something that I've come to love, because if you do a real product, it's absolutely wonderful not to have to worry about how much load you're gonna get. And this is true in two senses. It's true in the sense that, you know, you can live for the weekend without worries, no? Because, you know, if there is a you know, some certain peak of traffic, it will be handled, okay? And it's also true because of this other reason, which is even more important if you do a company, that is at some point, you will get publicity via something, okay? Maybe it's an advertisement campaign you do, maybe it's something that goes viral, maybe something that gets widely shared, but there will be these spikes in traffic, okay? So normally, not for very large companies. If you're very large, you know, your traffic is smoothed out. But when you're starting to get a product known, your visitation graph usually looks like something like this. You know, you're barely making up some traffic, and then boom, there is this huge spike because something went viral. And then when it lands, it doesn't land at the previous level, right? But it's above, because a lot of interest is just momentary. But some of those people that went there decided, oh, this is a cool thing. Let's start going there. You know, it sort of increases the base, and then it goes on, and then maybe you do some other advertising, and boom, you get another peak, and then you increase again, and you do some. This is, you know, typically how it looks. The problem is this: that up to here, maybe you have spent 3 months with a certain traffic level. And you know, if you pay for advertisement, then you know when the peak comes. But often you don't, right? Because one of these people that has a lot more followers than the others on Twitter picks up on what you're doing and, you know, starts spreading it. And so the problem is that when these peaks come, either you're quite ready or you're gonna miss a lot of the publicity effect, and it's a pity, right? So that's part of the reason why I really like autoscaling. There are these two reasons combined. The one is that, you know, I don't like to babysit my work. I like to test it, but then I like to just let it run. But the other reason is really that if here you realize that the Twitter storm is coming and that you are going to get 10x the number of visitors, you know, it's bad to have to worry about scaling where you are very much in a hurry. Because yes, you can bring up more instances, but what about the load balancing? Did you test it? And when you do these all yourself, all of a sudden, you always discover that you forgot about something. It's always like that. These two, Appengine and Managed VMs, also come with something that people love and hate at the same time. I've learned to love it, but it's certainly peculiar. That means the HTTP calls have a 1-minute deadline if you do them in real time, and they have a 10-minute deadline if you do them in a queue. People hate these sometimes because they want to do longer processing. I've come to love it, because one of the typical things that happens, actually, if you do roll yourself your own server, is this, that you decide to reply to these HTTP calls, and then something goes wrong. I don't know, you cannot get a connection to the database because, you know, network problems, or else you do a silly bug and you get in a loop, or, you know, I mean, there are many things that can happen, right? Including that your local operating system and it goes bonkers because, I don't know, it's trying to do a security update, whatever, right? But there are these things that disasters that strike with a low probability. But the problem of rolling out yourself many servers is this, that eventually one of these servers will get stuck. And suppose you have 10 servers, one of them gets stuck, fine. The day after, another one gets stuck. And if you are not notified when this happens, pretty soon you have a significant part of them that get stuck, and then you have few of them that can actually respond. This is a problem that I've seen happening very often, actually. Not on Google App Engine, but on things hosted, say, on other cloud infrastructures. The problem is that you think you have 20 servers, and then they one by one die. They don't really die, but they get in a situation in which they are unable to respond to further requests. It can be the silliest of things. It can be that the log file has become too long, and you have run out of space in that particular thing that is mounted there because of that, whatever. And so when you get the next request, you simply dies instead of responding, right? So this ability to actually limit the running time of every request is actually very good for long-term reliability. It means that nothing gets stuck, essentially. Okay, so I like it quite a bit. Aside from these, there are two solutions in the Google Cloud that are shared with the Amazon Cloud, which is that you can get the compute engine VMs. Okay, and these are just very normal VMs. So you can you can build yourself the VM, you can SSH into it, so you don't need to give a declarative instructions on which packages you install into them. These managed VMs, you need to define how they are created. You don't need to create them, you need to define how they are created, which is slightly more limiting. Here instead you can get into the VM and tinker with it as if it was your own local computer. Okay, the problem is that because you created them by tinkering, the infrastructure does not know how to duplicate any number of those. So both Google and Amazon work on this principle that you create this virtual machine by tinkering into them as much as you ever want, and then I describe the Amazon way because it's a bit clearer to my mind. But and then you take this virtual machine and you freeze it in an image. An image is like I don't know. The freeze-dried virtual machine, is it's essentially the imprint of the disk before you use it. Okay, so once you have an image, you can have this image run on every number of VMs. But it's a slightly laborious project. I mean, you tinker your virtual machine, then you freeze it into an image, and then once you have the image, you can duplicate it into many ways. Okay. This works, but then typically the decision of how many of these copies you have around and where do you direct the traffic is left more up to you. So if you look at this, the services available, Amazon has load balancers, has many other tools. And so when you bring up a new virtual machine, you have to say essentially, okay, bring up this new virtual machine, then the service will somehow tell you what IP address internal to Amazon the virtual machine is running at, and then you need to give your load balancer, hey, look, when you get a call, there is this additional virtual machine that you can send requests to, okay, and then it gets inserted in the load balancer, and then it will start getting requests. And when you want to speed it down, you need to do the opposite, right? You need to go to the load balancer and say, look, I'm removing to you this IP address. Okay, fine, so no more requests are queued. Then you have to wait a little bit until no more requests are being processed by that machine. You don't want to just pull it off like that. And once that is done, you can speed it down. So you can essentially stop running that image on that particular virtual machine. Okay, so it's a bit of a laborious process, but the advantage is that you can do fully custom stuff. Okay, there. So this is a sort of panoramics. Now let me go a bit into this Web2Py App Engine class that we did, and I want to see if we had, okay, so this is one, okay, and this was the other one. Okay, I want to talk a bit about these various files. Okay. I'm still getting used to this tool, actually. I used to use Emacs. Maybe I should just use Emacs. But let me try. So I want to open, it's in work, web2py, app engine class, web2py. Okay, so here in this directory there are various files, and I want to describe briefly what they are. One is app.yaml that I want to mention again. Okay, so this is essentially the file that explains how this is uploaded. Okay, we went over it again once already, but let me just do a quick summary. Application is the application you create on Google App Engine. So this is the app ID that you got when you created the app from the App Engine UI, okay? Version is a test. You can have many versions up and running of an application. And you can also do load balancing, okay? Maybe we should try, if you like, to do some load balancing. Load balancing, no, sorry, traffic splitting, not load balancing. Traffic splitting is very useful if you want to try new features, provided these new features do not require a different database. Because, well, you can also do that, but it becomes more complicated, right? To manage two different versions of your app that expect two different database layouts, because either you connect them to two different databases or you're gonna have trouble. So but the easiest case is one in which the two versions of the app expect the same database layout, but they work in different ways. For example, you just made a modification and you want to just have 5% of your users use it to see, so that if it breaks, not everybody's unhappy, okay? Or another use that is actually very nice is this. When you experiment with home pages, at least this happens to me. By the way, the homepage of CodeGrader is, I really need to change it. Is there anybody who knows somebody who is good in graphics, graphic design, and that would like to help me redesign CodeGrader, the landing page? I would love to get some help. So if so, talk to me. But so suppose I have a new landing page. I may want to try to measure whether people like the new one better than the old one, right? And so I can do the traffic splitting between two pages, or I can do it between two color schemes. The way I see it most used, there are these very useful sometimes meetings of people who use the Google Cloud. Google invites some companies to, I get to go because of the teaching and other things. And so I hear what other people are using it, and I would say the most common use of traffic splitting is that when you roll out a new feature, you don't want the system to break all at once. You want to roll it out to big, companies that have a lot of traffic. You typically roll it out to 1% of the users. Then they wait half an hour. They see how that works. They look that there is no bottleneck in the database or in the processing, and that there are not too many errors. Then they roll it up to 5%, 10%, and then to everybody. Okay, but so they do a gradual rollout, and this is very useful. Okay, sometimes it's very difficult to predict how users and how the system reacts to an entirely new feature. Okay, so these are versions. API version, I don't know what it is, I forgot, but it's always one, so don't worry. Runtime is Python 2.7. Thread safe is important. Thread safe true means that Google App Engine can send multiple requests to the same VM. Okay, so the same running core may be handling multiple requests concurrently. Okay, now this is good because while your instance is say waiting for the database, there can be another request that is being serviced. Okay. Now, threads in Google App Engine work in a very slightly different way from the normal, and I tell you in case you need to know it. But essentially, is this. Normally, you would expect, or I was expecting, that when you get a request, a new thread is created, the thread executes the request. At the end of the request, the thread dies. I mean, it is killed, right? And so a new request will run in a new thread. This is not what happens, however, okay? So threads can be recycled from one request to the next, okay? So you are not sure that you get a fresh thread when you get a new request. Why do I say this? Because, for example, in my code, not in CodeGrader, but in some other code I've written, I wanted to have some thread-specific storage. If you look at Python libraries, you can have some thread-specific storage. And I wanted to do essentially some level of caching by hand of the database myself inside the thread, because it would save me a lot of time, okay? And the point is that when you finish a request, your thread is not killed. So the next request may get a thread that is not fresh. So you need to remember that, right? Because if you use a thread-specific storage, it might happen that at the beginning of the request, your thread-specific storage contains garbage from the previous request. So you have to be a little bit careful there. Okay, it can be an advantage or a drawback. The other problem that I had to discover the hard way with this thread safe yes is this. If you write your code well and your code is computationally intensive, you end up writing Python code that spends most of the time processing rather than accessing the database. Okay? Google somehow in the scheduling model, this is, I believe it is this way, but it's empirically discovered information. But Google in the scheduling model that it has is that it believes that typical web applications spend more time waiting for say, the database than processing, okay? What does this come to? It comes to this very nasty phenomenon that as your traffic grows, suppose you get 1 request per second, fine, you're doing great. Now you get 2 requests per second, okay? Google somehow believes that, Google spins up a new instance. The parameters are not here. But I could show you the ones of CodeGrader just because it's a more complete example. Okay, so let me show you how this file looks in CodeGrader. Okay, so this is my where is it? Yeah, this would be it. This is the same thing in CodeGrader. You know, I say max idle instances for. Minimum pending latency before I spin up a new instance is 1.5 seconds. Maximum pending latency is 2 seconds. I don't want any request to wait for more than 2 seconds, otherwise I spin up a new machine. Max concurrent requests is a max concurrent requests per VM, and I set it equal to 2. Okay? Why do I need to pay a lot of attention to these max concurrent requests? Is this too dark? Maybe I should switch color scheme, right? Any experts that can tell me which one is the best? What, solarized, sunburst? Hey, expert. Okay. Thank you. I'm still learning the tool. So the problem is this, okay? That Google measures how busy the machine is by how fast it can queue a new request into it. Okay, so what happens is this: you start to get 1 request per second, you're fine. You get 2 requests per second, and you become busy. Okay, now Google starts to send you 3 requests per second to that particular VM. And what happens to Python? Python can start it all right, the 3rd request. Okay. But then it spends a lot of time because it becomes a CPU bound, trashing from one thread to the other, okay? But Google still thinks, hey, this started pretty quickly, so I don't need to spin up a new machine, right? I spin up a new machine only when the delay is about 1.5 seconds. So yeah, I get 1 more request, and now your traffic goes to 5 requests per second. And thinks, okay, well, let me just, pack these into your VM. And so what you notice is a very strange phenomenon that if you haven't taken the OS class, you may be wondering, well, what is happening. Maybe you know that the typical request, you process it in 1 second. Now you start to see that every request, you process it in between 10 to 30 seconds, and you don't know really why. And if you try to trace what is happening, you see that mostly you are doing nothing in these requests, okay? So you take more and more time but you don't do anything useful at all. And in the end, everything dies because there is this 1 minute timeout for requests. So what is really happening? What is happening is that you are increasing to a large degree the number of concurrent threads that you are servicing on the same VM. Okay, when you increase it in that way, what happens is that in OS terms you start trashing. That means you start having not enough memory to keep all these threads in memory, and you start to swap these threads in and out of memory, and so your effective throughput in terms of computation that you get down actually drops down. Okay, so you have to be very careful. This you have to tune it manually. You never have to give these max concurrent requests bigger than you can actually handle. And the only way to know what you can handle is to provide it a little bit. For example, in CloudGrader is 2. I should have used 1, but 2 is still somewhat okay. In CloudGrader, I think I spend, on average, because there are many different requests, but on average, I spend 2/3 of the time thinking and 1/3 of the time waiting for data. In another application I wrote, it does image processing, so it's much more CPU intensive. There, I actually spend 90% of the time thinking and only 10% of the time waiting for data, because the data I wrote it very carefully, and I don't need a lot of data. Instead of thinking, I need a lot of thinking. So in that case, if the balance becomes quite extreme, you are actually better off to switching thread safe is equal to false instead of true. Because if you set the thread safe is equal to false, then Google will never try to queue another request before the other one is done. And this essentially avoids any kind of swapping in and out, leaves the content of the cache the same. And in practice, I noticed experimentally works much faster. Okay, so in CloudGrader, I do this too because I want to save a little bit of money, and I don't think it's so critical there. But otherwise, 1 would be better. Okay, then runtime Python 2.7. There is not much to be said. Default expiration, I already told you, this is for static files. If you leave these two on too long, what happens is that any CSS or any JavaScript you have will be served stale, possibly by a large amount of time. Okay, this is a very hidden and very nasty cause of mistakes once you deploy to Google App Engine, because they say, look, I've just updated this in my JavaScript. Why does it keep serving the old one? And the reason is this, that it's a static file, the JavaScript, and you don't expire it fast enough. Okay, this can catch you. I mean, it caught me fairly often. Then you define a lot of handlers, which in the case of Web2Py is not particularly interesting, because the handlers basically are reduced to one line. So there are some standard ones. You basically don't have to modify a lot this file. And then there is one that says, well, any URL, you give it to guy handler, GAE, Google App Engine handler, essentially WSGI app. Okay, and so that's what you do. This handler is something that you need to put in the top directory. Is this GA Google App Engine handler? It's usually in a directory called handlers, where there are many different handlers. You need to copy the Google App Engine handler, with this one. You need to copy it to the level above. Otherwise, things don't work when you deploy. Okay, so you have to be careful about that. Now, what else does this file contain? So nothing very special. I mean, it contains various other things, but you don't need to worry so much. So other files that you may want to pay attention to are these. One is, I just described them, but hey, where did they end up? They move things around, and sometimes I lose track. Oh, okay, I haven't installed any one of them, but there are these files called routes.examples. Okay, these files are used to define spatial routing, And in general, I don't do any of that, okay? But the one thing you do is that in one of those files, if you copy to the top level, you can define what is the default app that gets run when you hit the site, not specifying any app. For example, if your app is called My App, you can say that the default is My App. I mean, that's why in CrowdGrader, when you hit the empty URL, you go to the CrowdGrader app. You know, I could have other apps running there. In fact, you know, I do have also like a login app and whatever app that I use for whatever else. But you know, you can define which one is the main one. Another thing that you can do is you can define the queues. Okay. Now I don't have it here, but I have it in CrowdGrader, so I can show you a definition of a CrowdGrader queue. Queues are the task queues, and are defined in an extremely simple way. Sorry. It would be here, for instance, and with queue.yaml. Okay. So this is a definition of a queue. This is the queue that I use to do the statistical analysis, and you can define various parameters. I think the important one is how many processes do you want to do per second? Okay, I want to do at most one processing per second. And then the important one that I use a lot is max concurrent requests. How many requests per how many concurrent processing there have to be? And I say only one. Okay, just because, you know, it's not something that happens very often. But the maximum concurrent request is very useful to smooth the number of machines running. Let's assume, for example, that you do, I don't know, you do some code that takes, okay, a real example, some code that takes images and does processing, and these images are have to do at variable rate, okay? So you would have two choices. One is to process the images as they come in, and you can do that, and you know, then your the number of machines you have spun up will vary during the day and during the hour according to how much traffic there is. Fine, okay, that's one more way of doing it. Another possible way of doing it is this. You decide, look, I don't want to pay for more than 20 machines at a time. So you set this maximum concurrent requests to, say, 20. And then, you know, you have at most 20 machines in parallel running your image analysis, okay? And if you get more images than 20, you know, suppose that you do 20 in parallel, and suppose that your image analysis takes 10 seconds. This means that your throughput in terms of images per second is 2. I'm just making completely up the numbers, okay? But so if you get more than 2 images per second in your queue, then the queue will start building up, and maybe, you know, it will get processed later. But so process queues are incredibly useful for smoothing the traffic as well, and smoothing your pay as well, you know, how much you pay for this processing. And they have also this very beautiful retry policy that you can define. So if the process fails, you can say, for example, there, I try run the reputation system at most 3 times. Okay, I don't retry for more than 1200 seconds later, which is what 20 minutes. Okay, the minimum back off is 10 seconds. Okay, so if my run fails, I try at least 10 seconds later, and then I do 2 doublings. So I try after 10 seconds. If I fail again, I try after 20 seconds. If I fail again, I wait 40 seconds and then I try again. But I could, you know, define it in different ways. If I wanted, I could wait 1 day. It's only that in my case, you know, this computes the grades in CrowdGrader. So if it fails, I assume that after a quarter of an hour, the instructor knows that it has failed, and they will click the button again, you know, and it will happen again. So in practice, CrowdGrader is not very much used, but for other queues that, you know, might fail for other reasons, this is instead used. For example, you know, we do some queue-based processing of images in another company, and there are more reasons, because we get such much higher volume of images. Once you go to very high volumes, there is always the case that due to, you know, network or system reliability, you know, but maybe 1 in a million fails because of some funny reason you don't know about. For instance, you know, you get the image, but the data store fails to respond. Or, you know, the network fails to respond when you try to reach the data, whatever, you know. But when you have very high volumes, things start to fail just because the real world is unreliable. And so having a retry policy is very nice because it enables you essentially to ride over these momentary instabilities in the system that you're working on, okay, and keep the global reliability, okay? So this is this app.yaml. Another thing that I wanted to do is show you in detail and talk a little bit about the choices here in db.py. So if I go here, class app, models db.py. So this is always the file that contains some of the basic definitions. So so these are let me separate it here. Okay, these two lines on top are the main definition of how to connect to the database. Okay, and it says the following: if you are not running on App Engine, use a DB that is SQLite. This is what you have been running so far. SQLite is this trial DB. If you are running on App Engine, you use the data store with the NDB interface. The NDB interface is nicer because it's faster. It uses memcache to cache the data that you read from the data store. And the difference in speed is a factor of 10 roughly. So it's 2 milliseconds to talk to memcache, and it can be 20 milliseconds to get data from the data store. Okay, so it's very convenient to use these. But the beauty of Web2Py is that DB is nothing very special. DB is a variable that you define, and if you want, you can do various things. And here I want to show you various other things we could be doing. Okay, for example, one thing that I would recommend doing is this: connect to Google Bigtable. But we like it only well enough for the session. Okay, so I rename these and I say session database is equal to this. Okay, and this migrate enabled is equal to false. This I would do it once in production, but for the moment I comment it out. Okay, and then I say this is our trusted SQL DB. Okay, and what do I do? Hang on. Sorry, I'm a little bit navigating in this directory system. So this is the line I wanted. Okay, so if I go here, you can say my real database is Google SQL. Okay, and you can say, for example, here the typical thing would be to have the same app that you are using here. You would create the database in the same application. The application is UCSC Luca testing. So here I would have also UCSC Luca testing. So this is the name of the app. Okay, this is the name of the database instance, and this is the name of the database, like MySQL DB. Okay. And this would be sort of a MySQL instance. So let me tell you what these various things are, okay? And then you can comment out as usual. Migrate enable. Okay, and do this. Sorry. Okay. So let me tell you a moment, first of all, about these. This is the connection line that you need to use if you use an SQL database hosted on the Google Cloud. Okay, this is your app ID. So if I go to UCSC Luca Teaching in the console, let me do that in fact. Okay, so I can get here and I can go console developers Google.com, I can choose Luca UCC Luca teaching, okay, and I can choose under storage Cloud SQL, okay, and I can create an instance. I don't do it now. Well, I could do it, but let me not do it. I can create an instance. So if I did it, you know, this is my app ID in which I created the instance, and this is the instance name, my SQL instance. It would be, sorry, this is too long a name. Okay, but this would be the instance name. The instance of an MySQL is essentially, to put it roughly, it's essentially like a VM running MySQL server. Okay, so an instance corresponds to a machine. So in fact, you can define how much memory should your instance have. Okay, so there will be something up and running that runs this instance either all the time or on demand. Okay, and once you do that, now you have this beautiful instance in the cloud contained in your app ID that runs MySQL. But an instance can per se run more than one database, right? I don't know if you're familiar with MySQL, but once you have a MySQL server, the MySQL server on a disk, right, on a physical machine, can run multiple databases. It can host multiple databases on that particular machine, right? This is quite normal. And so, you know, you can create the database inside an instance. And so here is, after the slash, is the name of the particular database that you want to use. Okay, so see, now we are connected to two databases. And if I wanted, I can connect to as many of them as I actually want. So I could do this if I wanted. I can say DB2, my second DB is this. I may not want to build a new instance, but I can very well do this. Okay, fine. Now I connect to, let me give you a less silly example, okay? DB test is equal to this. Okay, and voila, now you have on the same instance, so at no additional cost, two databases. One is the real production one, and the other one is the test one. And now you could write a very simple if statement that decides which one of them to use. Let's do it. I copied from CrowdGrader a moment because I forgot how to do that. But you see, if I do this, I can get my version ID. Okay. Well, okay, but in this case, I would put an if then else. I would do the following. Let me do it. Okay, so this is my version ID, and then I can say if version ID is equal to test. Okay, then I want to run these lines. Okay, and else I run this. Okay, so no, something like this. So it's one of the beauties of Web2Py is that it's really flexible in terms of how you decide to connect to databases. Now, I don't recommend it, but if you wanted to have a super high traffic, one of the things you could do is that you could connect to 10 databases. For example, one of the ways in which I can make CrowdGrader scale to very large sizes if I ever need is this. In CrowdGrader, most of what happens is related to a single class. Okay, so most of the data interaction is for one assignment only. Okay, so I could do a very simple function. I tell you this just to see in your mind how to, you know, how to use things in different ways. Suppose I change CrowdGrader in such a way that every request tells me which assignment. The assignment is a number. Okay, like 327. Whatever it is. Okay. I take this assignment ID and suppose I make sure that it appears in every URL that is ever sent to CrowdGrader. So here in db.py, I have access to my request, right? It's already running, so I have access to my request string. So I would do this. Suppose that the value ID or the assignment ID is argument 0. I can say assignment ID is argument 0. Then I take the assignment ID modulo 10, say, and I decided to connect to a database according to the assignment ID modulo 10. In this way, I divide all the set of assignments that I'm hosting into 10 different databases, pretty much at random. So that if I get very high traffic, I can talk to any one of these 10 databases. Okay? Now, what is the choice? When do data need to be in the same database, and when do data need to be in different databases, right? Because what is the story that I use multiple databases? What's the drawback and what's the advantage? Okay, it's a complicated situation, but essentially the thing is this: if you split data in multiple databases, you cannot do joins anymore. Okay, so you cannot do a single query that in a single blow says, this row has a student ID that is equal to the ID of this other row. This works only if the two rows are in the same database. So every query that you send to the database is sent to a database, not to multiple ones. Okay, so you make sure that you need to make sure that every query can be answered by a database. In my case, this would be roughly true, because most of the queries I do are like, give me all the submissions to this assignment, and this can be answered by a database because once I know the assignment, I would be able to reconstruct the database. But queries such as, give me all the assignments to which I've submitted, if I'm not careful, those, cannot be answered by any given database. So I need to pay attention to those queries, okay? So you need to pay attention to how to answer your queries in practice. The advantage is that every database, every MySQL database has a limited bandwidth to things it can process, right? A typical limit may be, some hundred of active connections, so some hundreds of active virtual machines that are trying to access the database, and some dozens, 1 or 2 dozens of active transactions. You can push up these boundaries, but it's hard, sort of. You need to go to bigger database instances that have more memory caching. Okay. Now the flip side is this. Then you can say, hey, if I do my things correctly, maybe I can just use 1,000 MySQL databases and I scale to super duper large sizes. There are 2 drawbacks. One is the one I mentioned before, that you have to be sure that every query has to be answerable by one of those databases. The other drawback is more subtle, and that is when you create your application inside the Google data center, Google is trying to put the database instance close in terms of the network to where you run your code. Now it has all these very complicated, that I know nothing about, algorithms in order to try to keep your data close to your computation, so that you don't cross the whole data center when you try to run the queries, right? And the problem with that is that if you now start to have 1,000 database instances, they will not be able to be all closed. No? So at some point, you risk that the network inside the data center will be the bottleneck. And unfortunately, you don't know very much about the network in the data center. It's typically not something that you get to see how it behaves or monitor. Okay, so there is a sort of trade-off there. The Google Data Store, this thing here, the Data Store plus NDB, that's very scalable. Okay, so because it's fully distributed across machines and across data centers, so it's not very likely to give rise to network bottlenecks. Okay, so but one of the beauties is that here you can completely arrange what you are doing. And so the other thing I wanted to tell you is about this session DB. What am I doing with this session DB? So when you deploy your app, every single request that you have will contain a cookie. Okay, because even if the user is not logged in, there is this session, and Web2Py gives the user a cookie. You can see that it's there, and the cookie contains an ID. Okay, so fine. So the user has a cookie and makes a web access, and this happens even for AJAX requests. Okay, so the request comes in, there is a cookie, and what does Web2Py need to do first thing before it even does anything related to you? Okay, it does the following: it takes the cookie, it looks for the session ID, and it looks up for the session information inside the session table. So you need to define where you keep the sessions information. Okay, the session information contains various information. You know, when you say like session.message, session.flash is equal to I'm very happy today. This I'm very happy today is put into the session database. The login credentials are put inside of the session. There is various stuff. Usually it's not huge, but it can be 1 or 2 kilobytes typically of information that sits there. There is a lot of information about your browser, your time zone, your whether it's mobile or not, your user agent, and a lot of other stuff. You know, I mean, you can print it out if you want. It's not huge, but essentially it's an access that you pay every time. So I've spent myself a lot of time thinking and debating where this should go, okay? But in the end, doing it as I'm doing it now for you is the best. So let's examine what are the various choices, okay? There are many choices for putting these. For example, you can store the session in memcache, okay? If you store it in memcache on Google, the response time is very, very short. Memcache is super fast. You can read it in 1 or 2 milliseconds. So it sounds very, very good. The drawback is this: memcache does not guarantee that it stays. So if you don't use it for 1 hour or 2, you may be logged out automatically, because once the session is lost, your login credentials are lost. Okay, so that's one of the consequences. The other consequence is that if you memcache is not promised to be always available. Okay, so there are periods in which Google reserves the right not to give you any memcache. I mean, I think it happens very rarely, actually, but it happens. It happened to me every couple of months for 10 minutes. I may not have make an incredibly sweaty memcache. And in those 10 minutes, you know, your users would be logged out at random. So in the end, it's not a super fantastic solution. You can put it in your MySQL database. The problem with it is that I like to keep my MySQL database small. And the problem is that this session information per se does not get deleted by anybody. So if you say, well, you logged in now, in 1 year, the session table will still contain, you know, your old cookie ID with your old session information. This is, of course, not very good, right? Because the session table will grow then without bounds. Every time you log in anew, there will be a new entry there because it will be a new. It's not only proportional to the users; it's proportional to the number of logins you have. Okay, so this grows and grows and grows, and so I really don't like having in a MySQL database something that grows without bounds, because I like to keep my MySQL databases as small as possible to keep most of them cached if I can. Okay, so for lack of better things, the best solution I found is to connect it, not to the DB, sorry, but to connect it to the session DB that I defined above as being on Google Data Store plus NDB. So using NDB gives me memcache, and so I lose on average just a few 1 or 2 milliseconds every time somebody accesses, okay, which is a low enough penalty that I don't care. And the data store is it's scalable. It's incredibly cheap as well in terms of how much you pay per gigabyte. So essentially you can go 1 year at a time without bothering. And then, you know, after every few months, the session table contains an expiration date field, and you can simply run a job that will delete everything that is older than, you know, a certain amount of time. And so you clean up your session table from time to time. But so this, unfortunately, is a sort of crucial choice, you know, where this session information is. Normally, it's hidden from view to you when you use Web2Py, but in this case, it's actually you need to really pay attention to that. Okay. And the rest in db.py, I think you know it already from the you know, from the various things we said during the class. So there is auth and there are the other things. Okay, and there is this logging that I gave you that is actually incredibly useful when you develop. I don't know, I think this concludes a bit my tour of the sort of non-trivial things that I wanted to tell you about the setup of a Google App Engine instance. Let me think if there is any other. Okay, so some other things that are fairly obvious. Actually, some things that are maybe not so obvious. When you are in, if you do run on Google App Engine gives you access to something that is called the user object. Okay, the user object corresponds to the Google login, to the Google identity of the person. Okay, I found myself that it's best to rely on that rather than to rely on the Google App on the Web2Py instantiation. I think now they have essentially fixed most of Web2Py code, but there used to be some instability at the beginning. I need to tell you because it used to be maybe still is a very big security hole. So if you run on Google App Engine, you have two notions. Let me again show you CrowdGrader code because I solved the problem there. Okay, but essentially, in CrowdGrader, I wrote this method that is called get user ID, get user email. Let's go over it. Here, I want to know the email of the user as defined by the Google service. This, in most cases, for you when you use CrowdGrader, is your ucsc.edu email address. Okay, so it works this way. If I'm running on Google App Engine, from Google App Engine API, I import users as Google users. I just want to avoid, a name clash, but this is the user service, okay? And then I say, U is Google users get current user. If you read the documentation of the Google API, let me show you where it is so that you know what I'm talking about, okay? But if you go here, and if you go here, you do Google App Engine user API, okay? And users Python API overview, okay? And so this contains user is equal to users get current user, and there is all the documentation here, okay? So you can read it. But coming back to the example, I get the current user view. If U is none, then I say none because you're not logged in and I don't know your email. If you are logged in, otherwise I return u.email.lower. So I return the lowercase version of your email address, okay? So that's guaranteed to be your Google email, which is what I decided to base all my essentially identity on. Okay, I base my identity in CrowdGrader on emails. I found that using emails uniformly rather than user IDs as Web2Py makes it easy for you to do is a very good idea because it has several advantages. One, I mean, it's less efficient from a system point of view because an integer is shorter to store than an email address. But for example, suppose that I want to invite Rakshit to be my colleague in a homework submission. He may not have joined the system yet, so he may not have yet an ID in the auth user table. But he has already an email address, right? That is already fixed. I can ask, hey, what's your email address? Actually, I forgot what it is. It's Ragrava1 or something like that. Ragrava1. But so, if he can tell it to me and I can use that as his ID even before I know who he is when he joins me in my particular app. That's very convenient, okay? That's one advantage, really. That you can have references to people that are known outside of the system. There's a sort of notion of stable identity. So I like this a lot. Now, this carries a huge problem, though. That if you use the normal authentication of Web2Py, you end up in this incredible problem, okay? That I don't know if it's still there in Web2Py, but used to be there. It used to be this. I log in, and when I log in, I'm called luca@ucsc.edu, and I'm Luca de Alfaro, and everything is very nice. Then after a while, you see in CrowdGrader, I say, of actions disable, append email, like verify email, etc. But essentially, I disable in some place here. Where do I do it? Email, reset password, change password, verify email. So I prevent you from registering, for instance. And I prevent you from changing email. The problem if I let you, where do I disable the email? Sorry, now I'm a bit lost. But I disable it. I think this is what I do. You need to disable people's ability to define their own email if you do this. Because otherwise I can log in. I'm logged in on Google, right? My Google email address is lookatUC.edu. But if you don't remember to set up email verification when you register, I can get ragrava1 at ucc.edu myself if you don't verify it. Okay? And then, you know, I can, or in general, for example, I also have other email addresses. So, you know, I'm also look@faro.com. And so I could, you know, join with the look@ucc.edu, which is my Google identity. And then I can change my email address. And at this point, I have two different email addresses. And the email addresses in my off-user table, and I have the email addresses of my Google identity, and they diverge. So you need to be quite careful about this. I think this can be a source of trouble. My preferred approach is that if you let people log in via Google, that you just trust the email address you get via this method, get user email, okay? Or get user system email is the same, but it doesn't do the lower casing, okay? And you just don't pay attention to what you have in the profile, okay? You force it to be that, okay? So that's one gotcha that otherwise was it was, you know, leading to strange consequences, I think. Other obvious things you can do in db.py is this. I always define something like this. If the Google account email is, say, look@ucc.edu, so I have a function that is called isUserAdmin. And this returns a Boolean that tells me whether the user is a super user of the site, yes or no. And if the user is a super user, I may have, you know, the site behaving in a different way. For example, I may, you know, let you see stuff that normal users cannot see. For example, you know, on CodeGrader, obviously, since I'm the site admin, I can see all the assignments, not only mine, no? Because I need to be able to know what's going on in the site. So I have this function that is called, you know, isUserAdmin, and my code in many places contains, if it's user-admin, then, you know, I don't know, do this and that, and describe this information to the web pages and do this various stuff, okay? So db.py is, again, the place where you need to do this kind of things, okay? So, yeah, I don't know. Is there any other information that I should give to you about hosting? Or yeah?
Does it cost money to start using Google App Engine, or does it just cost money how many like people visit your site?
Yeah, so you get 20 hours a day that are free, 28 hours, but the service is up on demand, right? So it goes up, and then I think when it receives the last request, an instance leavers on for something like 10 minutes, and then it goes on. You can decide on how long. But so, you know, in practice, Google Appendix percent will depend this. You need to define, though, an account with your credit card, unfortunately, if you want to switch on the database. The database is, again, if you keep it on for a month without interaction, is $18 a month. But you can keep it on only on demand. In which case, if it stays always on for a whole month, it may be more, like $25. But it's not only while you test it, it may be like $2, $3, $4. Then, you know, there are quotas. I mean, I can show you actually in some console of some of these projects what the pricing is for some of these things. Like if I go here and I go to App Engine, I can go to the dashboard, I guess, and it would contain some of the prices. I hope, well, it doesn't contain a lot of prices actually. I don't know, here it doesn't tell me. But for example, 1 gigabyte of storage, maybe $0.0009 per day. So, you know, I mean, it's mostly cheap. When it starts to become expensive, Google App Engine, is when it starts to get a lot of traffic. Let me give you a real example. I picked some time ago at UCC a tool called Wikicast that was analyzing in real time all the links to Wikipedia. There are maybe 3 edits a second. Wikipedia is maybe
3 terabytes of text compressed, and then it's maybe half a gigabyte of MySQL database. And every time you process one of these edits, I needed to read about 10 previous revisions and do all this match stuff, etc. So here at the School of Engineering, at the time I had bought dedicated servers. I had 2 of them for a total of $15,000. Okay, so these were 2 servers with rated drives, 8 CPUs each, were running very nicely, etc. Okay. You know how many power outages we have in the School of Engineering, and so every time it was a big mess because the database would go down and everything in here was driven nuts by that. So I thought, how much would it cost to host these on Google App Engine? So you make the calculation, not for gigabytes, but how much would it really cost for me to have 5 terabytes of storage with enough bandwidth, with enough read and writes, etc. And if you do all the calculation, you come up with a couple of $1,000 a month, which means it's not pocket change anymore. If I had a company that was running wicked fast, I would seek funding and I would go on doing it, I guess. But since this was a university project, and since I would have to rewrite my code because it's not actually written in Python right now, actually I could probably run the same code. I should think about that. I should think about seeking funding and running it in this way. Because now I could put my code, which is written in OCaml, a fairly esoteric language. I could put my OCaml code in a managed VM, okay, without having to rewrite it all. And I would be able to auto-scale on demand, and I would be able to do the storage. Maybe that would cut on my computation expenses, because managed VMs, I have a feeling, are more efficient per CPU cycle than App Engine. App Engine, I think, pays a lot of penalty on the fact that it runs on this runtime, Python runtime that is not the standard one. It's slower than my laptop by a factor of maybe 10, right? Well, I'll also use the cheapest instance, I guess. But so, if you do these kind of things, then it starts to be expensive. So if you do it for your own pleasure, it's one calculation. If you do it for a company, it's also a complicated calculation. Because, I've seen companies that do it extensively, and the point is this: you can say, okay, fine, I own my own and I have my own servers. Yes, but then you essentially need one more person. One more person is how much? How much is one person in Silicon Valley? A junior person. How much would it be? $7,000 a month, including more, right? Because as you said, benefits, etc. 10,000 a month, 8,000 a month, something like that, right? Between those numbers, no? And so, do you get one person, which requires speed, can be up to speed and do everything, or do you pay more until you pay more than $10,000 a month to App Engine, and then you think if you want to switch to that? It's difficult, right? Because it's very convenient also to push code to Google App Engine rather than, I mean, I realize this sounds nasty, let's try to hire fewer people. But I mean, in practice, it's a complicated equation, right? Because, sometimes money being equal, you are better off just postponing the problem. And just paying a little bit more to go faster, and then maybe you raise some more money, and then you hire more people, not only that person, but various more, because you were able to get funding enough. So maybe you can do that instead. I mean, there are complicated strategies when you start a company. If I were to start this as a project, it's also complicated, because suppose I write an NSF proposal, the National Science Foundation may give me money. The National Science Foundation is typically not super happy in seeing my money going to Google App Engine type of service. They want to they would much rather that I buy hardware and then pay a student to maintain it. It's just a model of, where they want the money to go that is done that way, And so it's only my model of that I will not pay to have a physical server kept up, just because it's too much mess, with all the blackouts. I mean, it's too much pain to have this happen. I mean, this discussion can go on for a long time, but I hope this gives you an idea. And so there are services like CodeGrader that actually are incredibly cheap. I don't know how much I spend, but I think I spend below $30 a month, below $1 a day to keep it running, not for UCSC, for everybody. And
And there are services that are instead much more data intensive, that would be much more expensive to run on App Engine, right? Just like, I don't know what, but there could be some with more computation. Other questions I can... Write to us or use Piazza if you have any problem deploying, okay? And we try to help. Okay, so here are the teacher evaluations. Who wants to volunteer to bring them back to the School of Engineering? You, okay, thank you very much. So I don't know if there are special instructions that I should give. No, I think there's fairly self-explanatory. So let me circulate some. There are more copies, okay? Okay, thank you. I'll now shut off this. So give us the envelope. Yeah, I think they can just, there is a drop-off box. Let me stop this hangout that I cannot find anymore. Yes.